Bismillahirrahmanirrahim. We are going to start our chapter 2 with a unit 8 in which we will study about electromagnetic spectrum. The electromagnetic spectrum is the range of all type of electromagnetic radiations. Radiation is an energy that travels and spread out as it goes. The visible light that come from lamp in our house or the radio wave that come from radio station are two type of electromagnetic radiation. The other type of electromagnetic radiation that make up the electromagnetic spectrums are microwaves, infrared light, ultraviolet light, X-rays, and gamma rays. In this chapter, we start about electromagnetic spectrum, and then we discuss about what is modulation and types of modulation, and then we discuss about in detail about analog modulation. In the previous unit 7, we explored and discussed the Laplace transform, which is the last article of chapter number 1. Now we are going to start off chapter 2. We will study what is the electromagnetic spectrum, what is the modulation, type of modulation, and then we discuss about in detail about analog modulation. Electromagnetic radiation is energy which can be represented by waves as electromagnetic waves. Electromagnetic waves are not just scientific abstraction, they are the lifeblood of modern technology and particularly modern communication system. By studying them, we unlock the secret of the universe that how these signals are traveled from one location to another location. It will help us to understand, to design the communication system, particularly antenna, receiver, transmitters. So these electromagnetic waves in different bands are exist in different bands and have different characteristics depending upon their frequencies as well as their wavelength. And there is a relation, very simple relation between frequency and wavelength. Maxwell equation predicted that the existence of an infinite number of frequencies of electromagnetic waves. And a good thing is that all these electromagnetic waves travel with the speed of light. This is the first indication of the existence of the entire electromagnetic spectrum. The main significance of the electromagnetic spectrum is that it can be used to classify electromagnetic waves and arrange them according to their different frequencies and wavelengths. In vacuum, electromagnetic wave travel with a speed of light which is 3 to 10 power 8 meter per second. Similarly, the wavelength which can be defined as the distance between two successive wave crests or trough, the wave can be described by wavelength and frequency, which can be defined as the number of wave cycle per second. And all these wavelength and frequency are related with the speed of light as c is equal to lambda f. Both electricity and magnetism can be static, but they can change or move together. When they move together, they make waves. In other words, we can say that electric field generate a magnetic field and magnetic field in turn generate electric field. And in this way, electromagnetic wave travels from one location to the another location. Both electric and magnetic field of an electromagnetic wave are perpendicular to each other as shown in the figure and the direction of the wave. Unlike sound wave, which must travel through a matter or bumping molecules into each other like dominoes and thus can be traveled through a vacuum like space. Electromagnetic waves do not need molecules to travel. They can travel through air and a solid object and even space, making them a very useful a lot of technologies, particularly for wireless communication, communication between ground to the satellite and satellite to the ground, and even from ground to the ground to the satellite. The electromagnetic spectrum spans an immense range of wavelengths and frequencies, and it divided into distinct regions based on their properties as well as their application. Starting from the longest wavelength radiation, the electromagnetic wave, we have radio wave, with the wavelength ranging from a few millimeter to thousands of kilometer, and frequency below 300 gigahertz. Radio waves are very useful for broadcasting, communication, and even exploring space. Think of your favorite radio station or GPS system that are radio wave at work. Moving up, the encounter microwave with the wavelength from about 1 millimeter to 30 centimeter and frequency ranging from 1 gigahertz to 300 gigahertz. These waves are critical for radar system, satellite communication, and modern mobile communication. And even heating your food in a microwave may use the same wave. Next, there's infrared radiation, often associated with heat. Its wavelength range from 700 nanometers to 1 millimeter, with a frequency from 300 gigahertz to 430 terahertz. Infrared waves power remote control and night vision devices and thermal imaging cameras. They are very successfully used for such devices. In the middle of the spectrum lies visible light, the light we human can see. The wavelength from approximately 400 to 700 nanometers and frequency from 430 terahertz to 750 terahertz. Visible light reveals the color of the world and enables life through photosynthesis. Beyond visible light is ultraviolet radiation with a shorter wavelength from 10 to 400 nanometers and frequency from 750 terahertz to 30 pentahertz. UV waves carry more energy while UV is essentially for vitamin D production. Too much exposure can cause sunburn. Even higher energy are X-rays with wavelengths ranging from 0.01 to 10 nanometers and frequency from 30 petahertz to 30 exahertz. These waves penetrate soft tissues, making them invaluable for medicine, medical imaging, and detecting structural defects. Finally, we reach the most energetic part of the spectrum, gamma rays. Gamma rays have wavelength shorter than zero point zero 0.01 nanometer and frequency exceeding 30 exahertz. Gamma rays originate from the radioactive material and cosmic events which are continuously take place at every time. And they are used in cancer treatment and atmospheric research.